Hello everybody, it is time to start recording the 4-1 worksheet. Every time I watch a YouTube video, the person's like, oh, there's construction outside, and I'm like, there's never construction outside. That's such a, there's always construction in people's YouTube videos. Well, today there's construction outside my window, so I hope you don't hear it. I hope it doesn't bother this video. Also, my cat is right next to me, so maybe she's gonna also be distracting. I have no idea. It's going to be an adventure. So, 4-1 worksheet, all about congruence. It's a good bridge between the last sections of chapter 3 and the beginning of chapter 4 here. So, if JKL is congruent to RST, give the coordinates for possible vertices of RST. Justify your answer by describing a composition of rigid motions that maps triangle JKL to triangle RST. So basically, we want to move this triangle with a composition of rigid motions. And there's like a zillion ways to do that, right? We can move this anywhere and still make it congruent to the original shape. We could do it the really lazy way and do two translations. So maybe I'll translate up one with one of my translations and translate over one with another one of my translations to give me J prime, K prime, L prime. Because, you know, in math we like to work smarter, not harder. So let's do that. Right, so we can say the two translations that we would need would be a translation over 1, so that would be like a 1, 0 translation, combined with a translation up 1, which would be like a 0/1 translation. And of course, you can do anything here. There's many answers, many possible answers. So you definitely don't need the same one as mine. Oh, it says give the coordinates for possible vertices. I guess we should write in the coordinates as well. So let's see. J prime would be -5, 4. K prime would be -4, 8. And L prime would be -1, 3. There we go. So we've got the coordinates in there. Number 11, Yuki says that if all lines are congruent, then all line segments must be congruent. Is Yuki correct? Explain. So Yuki says all lines are congruent. That is true because lines go on forever in both directions. So every line is congruent to every other line because every line is infinitely long. Line segments, however, they're not infinitely long. They have endpoints, and those endpoints cause those line segments to be different lengths. So the line segments are not congruent. So we can say no. We can say all lines have the same length. Have the same length because they are infinite. Line segments have endpoints, so they have different lengths. Line segments have endpoints, so they have different lengths. And there we go. Number 12, given square JKLM and this set of translations, what is the area of RSTU? Well, those translations represent a rigid motion, which means the area will not change. So the area of this shape is the same as the area of the new square. And since the area of this shape is 12 times 12, or 120, or 144, then that means that the area of the new shape is also 144. That's a pretty simple one. Number 14, given a reflection of PQR to give us P prime, Q prime, R prime across line N. And do P prime, Q prime, R prime, and PQR have equal perimeters? Explain. Again, this is just getting at the idea of congruence. And since these two shapes are congruent, they have a rigid motion between them, which means the side lengths are preserved. And since those side lengths are preserved, the perimeters will be equal. So we can say yes, they have a rigid motion between them, which means length is preserved and the perimeters are the same. Number 15, given WXYZ is congruent to WTUV, describe a composition of rigid motions that maps WXYZ to WTUV. So we can do this in a composition of rigid motions. We can also just do this in one rigid motion. Both of those would be acceptable. I actually was able to do this in one rigid motion. So what I did was I took WXYZ, and I said, what if I rotated it around point W? So if I took this shape and I rotated it around point W, then this entire line would come up, and it would be on this line, right? And then this entire line would come up and be on this line, so they would match up. So what I would write is this would be a rotation, lowercase r, and it's a rotation of 90 degrees in a counterclockwise direction, which of course is a positive direction. So rotation of 90 degrees around the center of rotation, which is point W here. There are, again, lots and lots of other ways you could show the different compositions of rigid motions that map them on there. But we know that because they are congruent, there will be rigid motions that map one onto the other. Number 16, are these two shapes congruent? If so, describe a composition of rigid motions that maps ABCD onto EFGH. If not, explain. So again, if they're congruent, that means we can find a rigid motion. And in this case, we can. We can find a couple different compositions or rigid motions that would work. One of them would be to rotate ABCD 90 degrees, or not 90, 180 degrees around the origin. So we could say it's a rotation of 180 degrees around the origin. There we go. And that would give us the new shape. Another option would be to reflect this over both axes. If I took this shape and reflected it over the x-axis and then reflected it over the y-axis, I would get the same shape as I have right here. So I could say that. Or reflect over both axes. Okay. Number 18, using a 3D printer, Emery makes a chocolate mold shown by copying different shapes. Which of the designs in the mold appear to be congruent? And describe a composition of rigid motions that maps the congruent shapes. So there's going to be a lot to this problem. There's a lot of shapes in here that can be congruent, and we can tell what rigid motion would map one onto the other. So for example, A and C are congruent by a reflection. Because if we reflect vertically through B, we go from A to C. So there's a lot of these. I'll write down all the ones that I found. E and F are congruent by a translation. Of course, they're both circles, so it could also be by a reflection from E to F, or it could be a rotation around a certain point. So there's lots of ways that E and F could be congruent. So I just wrote one of them. D and I said by translation as well. But there could also be a rotation through like right here that would cause D to rotate onto I. A and G whoa, hold on a second. A and G by a rotation around shape D. Also C and G by another kind of rotation. C and G by a rotation around a different point. And actually, we would need a reflection and a rotation to do from C to G. Reflection and rotation. Then we've got B, D, and I, because B is a square, D and I are both squares that have been rotated. So B, D, and I by a rotation, turning that shape sideways, by rotation and translation. Right? Of course, you could have different types of transformations here. There's lots of different ways to show that they are going to match up to one another and they are congruent. Those are the ones I had. Number 20, describe a rigid motion or a composition of rigid motions that can be used to make sure that each slice of quiche is the same size and shape as the first. So if we take out this first shape, it's fairly easy to see that we could take this one out and rotate it around the shape 7 times to see if these pieces are all congruent to the original shape, etc. So we can write that. Take the first slice and rotate it around. How many degrees? That would be 1/8 of that circle, which would be 45 degrees. So rotate it around in 45-degree increments to show that each slice is congruent to the first, or to check whether each slice is congruent to the first. And number 22, a board game token is shown, which is congruent to the token. This is a very easy question. There's lots of harder questions they could have given us for this, but C is obviously the one that's congruent to that token. All right, and that's it for 401. Hopefully you understood. If you've got any questions, let me know, and have a wonderful day.